is going to work. There. Okay, Jerry, do you remember your responses then?
Mm-hmm.
What did you measure, first of all? Okay. What was the length of your phone?
14.5 centimeters.
14.5 centimeters. Okay. So that's important right there for accuracy and precision. You were accurate to half a centimeter, or I guess to the 10th of a centimeter, because you would have, well, which side of your meter stick did you use? The one with all the lines or not? That side? Okay, so that one only goes to half.
Yes.
Okay, so you were accurate to half a centimeter. If you use the side with all the lines, and that has millimeters on it, so you could have said 14.50 with that one, which would have been to the millimeters place. But
it was also exactly on it too.
Cool. Well, but like it could have been almost to where you could have rounded to 14 flat or 15, and if you couldn't round, then you still say 14.5. So if somebody writes down 14.5, that's what we have to assume. So that's accuracy right there. I want to see what everybody measured and see if somebody measured the same thing, like one of these desks. Marshall, what'd you measure?
My phone.
Phone, okay.
Yeah.
Y'all have the same phone or anything?
No.
Jimmy, what'd you measure?
No,
Huh?
I think so.
You're supposed to measure it. You got a meter stick right there. Look at that activity and see, pick an object to measure and fill out that Google form. What you got, Colton? Phone, what kind of phone is it?
iPhone,
iPhone? What kind of iPhone?
like 6.
Okay, but you probably got a different case from anybody else that might have. Yeah. Harina, what'd you measure? Desk? The whole desk all the way to the floor?
Yeah.
All right. Hunter, what'd you measure?
iPhone,
Phone, what kind of phone is it?
Samsung A11.
Samsung A11. We'll try to remember that. Did you get to measure something, Caden?
I was about to.
Okay. Yeah, I know you had to go get that. That's all right. Francisco, what'd you measure? Just the top?
Yeah.
Okay. What'd you measure, Andrew? Book. What'd you measure? Just the top or all the way to the floor? All the way to the floor? All right. Well, we're gonna compare y'all's two since you measured. Let's see if you measured exactly the same parts of the desk. Y'all have different models of desks, so might not work. We'll try it out. So, Karina, what'd you get for the height of your desk?
72.2.
72.2 centimeters.
74.
74.0, or what'd you write?
74.
Just 74, okay. What about for the width of it? Sorry?
60.
60? So I guess y'all measure different parts for the width. But okay, what'd you say, 45 and 60? Okay, what about for the length?
86.
Okay, you said 60? Huh. Yeah, I think y'all just, one of y'all might have measured to the chair and one of y'all didn't, so. If we focus just on the height, what was that again? 72.2 and 74. Okay, so I'm sure that y'all made accurate measurements. Your desks are different, so. But if you have the same desk, regardless of exactly how tall that desk was, if y'all got different measurements, that makes the measurements imprecise. Because if you think about, there we go. If you have this is like a bullseye here. It's not a very well drawn bullseye, but it's a bullseye, I guess. If you hit the bullseye, would you say that that's accurate or not? Y'all participate with me here.
Oh, you say?
Is this accurate or not? All these
No,
attempts to hit the center.
no.
No, not really accurate. Dang, I should have done the other one first. Delete all these. What am I saying? Delete. We're doing too much virtual stuff, I guess. Now let's say you got all of them right here.
Yeah.
First of all, something's wrong with your device. I think you should probably check on it because that's weird. Maybe you tried all at once. They all came out at once, and that's why they ended up right there. I mean, good job holding it steady, I guess, but I wasn't pointed the right way. These are precise, but not accurate because they all had about the same measurement. Y'all's, the 72.2 and the 74, if you'd measured the same desk, would have been weird. It would have been not precise. Maybe one of them would have been accurate, but I don't know. I'm not saying that y'all's measurements are bad. Y'all measure in different desks. I'm sure y'all did great. But like this person is precise, but not accurate. The accuracy would be right there. So if they all were right here, that is precise and accurate because they're all together and they're all where they're supposed to be. So that's accuracy and precision. I know that I'm turning the projector on. I know that the video people won't be able to see it because the camera is not good at that. I don't want to insult the camera. It's very nice that Alvarado ISD got me a camera, but it doesn't work. So here are the rules for significant figures. And I'm going to write on the board, even though they're already on the board. Oh. So non-zero digits are always significant. This does tie in with the measuring we just did. Give me a minute, I'll show you. Virtual people, I'm sorry about that brown marker yesterday. I had no idea that wasn't going to show up. It's just a weird camera. Okay, so if you have, like 4023, 4023, that would have 3 significant digits because that 0 is not significant. The only non-zero digits it has is the 4, the 2, and the 3. We'll do examples actually written here. Second. If there's a decimal, final zeros at the end of the number are significant. So like Jerry, when I was saying with yours, if you'd said 14.50, that is a significant figure because it means something. It means that it's not just 14.5 and maybe you rounded from 14.45 or maybe you rounded from 14.54. That next digit could be anything if you don't write anything there. If you write a 0 there, that means it's exactly 14.50 and not 14.51 and not 14.49. Now you may have rounded from 14.504 if you had even more lines, if you'd measured it.
I just did.
Yeah, because if you'd had even more lines on there, you would have had the opportunity to measure even more accurately and say if there's a ton of lines that you could somehow see the difference between all these lines that are super close together, you could have said 14.50001. But there's no way you'd be able to see all those lines. Anyway, that would be a really accurate measurement. But all those zeros would be significant. If you said 14.5000, the end of the zeros at the end of that measurement are significant because that means that it's not 14.5001, it's not 14.5995. It's exactly 14.5000. All right. If we multiply or divide, I'm going to try to save space here. So if multiplying or dividing, answer must have the least number of sig figs that were present in the problem. That is not an S. So factors are the two things involved in multiplying, dividend and divisor are the two things involved in dividing. So like if we multiplied, are y'all paying attention here? If we multiplied Jerry's number 14.5, which has 3 sig figs, because it has 3 non-zero numbers, and we multiplied your number of 74, which has 2 sig figs, we're going to get a 3-digit number, but we're going to have to round it so that, let's do it. We're going to have to round it so that it only has 2, because this rule means the answer must have the least number of sig figs present in the problem. So if we do 14.5 with 3 sig figs times 74 with 2 sig figs, our answer has to have 2, so that's the least number involved. So let's see what that is. I have to change my mode, calculator mode. All right. The answer of, here's an example for this. Answer of 14.5 times 74 equals, I'm looking at my watch instead of my calculator. Wow. It's not even a digital watch. It equals 1073, but our answer has to have 2 sig figs. This has, well, it says 3 as far as we know right now. It has to have 2, so we need to change it to 2, which means we have to round it. That means this 73 is going bye-bye. So to round this to something that's close to, we can't just say 1,000 because 1,100 is closer. So that has 2 sig figs. That's what we got to do. And the reason for that is because we can't pretend that this is 74.0. Well, 14.5 times 74.0 could very well be 1073, and that would be fine. But saying that would imply that that's exactly 74.0, but we don't know that. So we have to say, okay, it's just 1,100 because they rounded and they rounded, and we don't know it more specifically than that. Oh, I'm not even on the camera right now. Oh, yeah, I am. All right. Those are sig figs. Let's do a few more examples so that we can practice this. Here we go. How are we doing here? 55? No, we're doing things. It's fine. All right. I'll write these here one by one because I don't think they can see that. 5.40. These examples use one more rule. I don't know why that, I gotta fix that for next class. One more rule is zeros between significant digits are significant. So that's why I was hemming and hawing about 1073, because that 0 is between a 1 and a 7, which are both significant because they're non-zero. Yes, I know, okay. Okay, so 5.40. I need y'all to participate here. How many sig figs does that have?
What did you have?
Number 1 up there, 5.40. How many sig figs does it have based on these rules? It's got a 0 at the end. That's rule 2. Final zeros are significant. Yo, we're doing stuff right here, right now. Don't be looking at your phones right now. The first one, we're not using the third rule because we're not multiplying or dividing. We're just looking at each number. So we're not going to use this one right now. We might use 1, 2, or 4. So it has non-zero digits. 5 and the 4 are significant. The final 0 is significant. So that's all of them. It's got 3. All right, let's see if we got. Now that final 0 thing is only if there's a decimal. It says if there's a decimal, final zeros are significant.
That's 2.
Yeah, 210 would have 2. Okay, Jerry, you're done. I need to make sure other people got it. Now that last rule comes into play here. Zeros are between significant figures. They are significant. So somebody else, how many does this have? 4. All of them. This 0 is significant because it's between 2 sig figs. Last one that we'll do. This is a scientific notation number, which we'll talk about maybe tomorrow. I don't even know. Maybe Monday. In these, we don't count these 10 and the 3. We're not looking at this. We're only looking at the number in front. So this has 2 sig figs because it's got 2 non-zero numbers. All right. Would y'all go to the closing activity and see if we can do that while we have time?
Not done.